Right, hi and welcome. We'll carry on with some analytical geometry from a past paper. There are two big questions in this particular exam. Right, so question 3 in the diagram below. M, they're not giving you M, right? T, they are giving you. N, X, Y, and P, 7, 3 are vertices of a trapezium. All right, so you can see there is your trapezium. There are the 3 points they mention. They are not mentioning M as far as coordinates go, but they do mention T, N, and P. There they are. And they tell you that this is a trapezium. And they have indicated that TN is parallel to MP. All right, so with parallel lines, we know that we have 2 lines that have the same gradient. So just remember that, because do you see that there you can find the gradients? You have 2 points, which means that if you have this gradient, you automatically have that gradient. Okay. They said TN is parallel to MP. They said Q11 is the midpoint of MP. All right, but it certainly is a point on the line MP. It's a midpoint. All right, so technically we could find A and B if we needed to by using reverse midpoint. They say PK is a vertical line and angle SPK is theta. All right, now you immediately notice that theta is in the middle of nowhere. So remember, if you want to use tan theta equals M, you can only find the angle of the x-axis. So that angle, if you needed to. Okay. And then they also said that the equation of NP is that. So they're giving you the equation of NP. Right, so the first question says write down the coordinates of K. All right, K is directly underneath P and the X value is 7. And the Y value obviously on the X axis is 0. All right, so K would be 7, 0. Whenever you find coordinates or lengths, all the information, please put it onto the sketch, because sometimes you think the information, but you've actually got the information. You just haven't indicated it on the sketch. Right, then they said determine the coordinates of M. And remember what I said, if they've told you that Q is the midpoint, even though they've given you the midpoint, you can find one of the end points, because the midpoint formula uses the end points to find the midpoint. So you basically act as if you don't have the midpoint. So the midpoint of MP equals. Now, how do we find the midpoint? We add the x's and we divide by 2. And we add the y's and we divide by 2. Right. So that's how you would find the midpoint, but we know the midpoint is 1, 1. So in other words, 1, 1 equals this. And if these 2 points equal each other, then the x must equal the x and the y must equal the y. All right. So 1 equals a plus 7 over 2 and 1 equals b plus 3 over 2. And then you can easily solve these two and find a and b. All right, so here we just multiply by 2 and we solve for a. So a is equal to 2 minus 7, which is minus 5. See, as I find it, I fill it in. And then 2 equals b plus 3. And so b will equal 2 minus 3, which is minus 1. All right, so we have that end point M quite easily. Right, is everyone okay so far? Everyone happy with that? No questions?
Yes, ma'am.
Okay, then they say determine the gradients of PM. PM is this line. Well, that's nice and easy because remember what I said right at the beginning, you have 2 points, so you could find the gradient, okay? So the gradient of PM would be 3 minus 1 over 7 minus 1. So 2 over 6, which is 1 over 3. Right, so that was pretty straightforward. Now, remember what we said, well, I said about this line. I said that there's an angle involved, but it's in the middle of nowhere. It is not off the x-axis, but we could find this angle if we had this gradient. And we do have the gradient, right? And we know that tan of alpha equals a third then, the gradient. So in other words, the reference angle would be arctan a third. Can somebody please tell me what that would be? Arctan a third?
Ma'am, I got 18,43.
Agrees with that? Adam? Tabitha? Tabitha, are you there?
Yes, ma'am, I'm here.
What did you get for your reference angle?
Let me double check once again, ma'am. I got 18.43.
Perfect. And because this is
Yes,
acute,
ma'am.
it is, alpha is 18,43. Okay, it is the acute angle. So this is 18,43. So in this triangle, you can easily find theta because you have 90 and that. All right, so theta will equal 180 minus the sum of the other two, 90 plus 18,43. All right, 180 minus 108,43 is 71,57. So roughly 71,6 degrees. Okay, just double check my algebra.
Hi, ma'am.
Hi.
Ma'am, I just wanted to ask how they got 18.43.
Shift tan a third, arc tan a third.
Okay, well, I got a different value,
What did you get?
20.48.
Really?
Yes, ma'am.
Serena, can you please check for me? I don't have my calculator here, so I can't check.
Ma'am, I got 18,43.
Zarina, are you sure that your calculator is in degrees? So go to mode or shift mode and make sure it's in degrees.
I'm sorry, ma'am, that was my mistake.
Okay, cool. No problem. Okay, perfect. All right, so you're happy with that? All right, now you do always get a question like this. You get quite an easy question. This is an easier type of question, okay? Then you also get harder kinds of questions as well that they sometimes want to give you. Just want to see if there was another question underneath this. Okay, there were. Calculate. It says determine the length of PS. The length of PS. All right, so it's the length from there to there. All right, so that length. All right, now this is called the x-intercept of this line. And if you had that, then you could do the distance formula, right? So it would be very nice if you had the equation of this line, PM. Now that's easy enough to find, the equation of PM, right? Y is equal to mx plus c, and m is the gradient of QP, right? Which we have not found yet, all right? So let's find the gradient of QP, which is the same line. So it is 3 minus 1 over 7 minus 1. In other words, 2 over 6, which is a third. Oh, we did. We had it already from here. All right, so there's the gradient. And now you're going to substitute it into m for the line. So y equals a third x plus c. And then we use one of the points on that line. I would use 1, 1 because the numbers are nice and small. Right, so if we find c, it'll be 1 minus a third, which is 2/3. So the equation of the line is a third x plus 2/3. And then we could make y 0 in order to find x. Right, LCD of 3. Right, so x equals minus 2. So this is minus 2, 0. And then I can do the distance formula. There's another way that you could have done this, an easier way. Right, and now you'll do the distance formula between P and S, because that's what they asked for. So PS is the square root of 7 minus 2 is 7 plus 2, which is 9. And 3 minus 0 is 3 squared. 81 plus 9 is 90, so it's root 90. Okay, and you can probably simplify that. Right, I want you to put in your calculator root 90 equals and see what you end up with. No, it's not that. Okay. What would you get for root 90 equals on your calculator? 3 root 10?
Yes, ma'am.
Okay. All right, so this length is 3 root 10. But what you could have done as well is you know that this height is 3, and you could have done opposite over hypotenuse. Opposite of hypotenuse is sine. Sine of 18,43 equals 3 over PS. And then you could find PS. So multiply by PS, and then you'd have to divide by sine. So 3 over sine 18.43. Just tell me what that gives you.
$9.49.
Oh yeah, that makes sense. And then work out 3 root 10 for me as a decimal and see if it's similar, and it is.
Yes, ma'am.
All right, so it's more or less the same. Okay, so that was a different way you could have done it. Right, then the next one they want is the coordinates of n. And n is the intersection of this line and that line, or that line and that line, or this line and this line. Okay? It's the intersection. Now, you don't really know anything about this line. But you do we know anything about this line? This has the same gradient, right? So we can find the equation of this line. The gradient of MP, we said, was a third, right? And this would also be a third, not so. But we need this line. And what did they say here? They said the equation of NP is y equals minus 2x plus 17. So if we had this line, then we could solve them simultaneously to find the intersection. So we actually need to find the equation of that line. So y is equal to m is a third, x plus c, and then we sub in the point minus 1, 5. And then you can easily find c. 5 plus a third is 16 over 3. So that line will be a third x plus 16 over 3. And I can solve that simultaneously with that. Because that is the intersection of the two lines. Now you need to realize that it's the intersection, okay? So whenever they're talking about letters in analytical geometry, ask yourself, is it a y-intercept? No. Is it an x-intercept? No. Is it a point of intersection? Yes, of 3 lines. Which lines should I use? I know nothing about this line, so maybe it's these 2 lines. Yes, they gave me that, and I can find that, and then I solve simultaneously. Remember intersection, the S in the middle, simultaneous equations. Okay, so now you need to solve those 2 simultaneously. And I'm not going to squeeze things on here because there's no space left, so I'll just clear this and we'll do it on the side. Okay. All right. Okay, so if we're going to take that one, that's a y equals and that's a y equals. So this can go in place of y. So a third x plus 16 over 3 equals minus 2x plus 17. All right, so I can definitely put these over 1 and do an LCD. Remember, when you have an equation with a fraction in it, LCD immediately. Because if every single term is over 3, you can multiply every term by 3 and then it's gone, right? So that's why when you do an LCD, it's gone, it falls away. X plus 16, that's missing a 3, so minus 6x. And that's missing a 3, so plus 51. X plus 6x is 7x. And 51 minus 16 is 35. And then if I divide by 7, I get 5. So far, the intersection is 5 something. And then all I do is I plug this back into one of the 2 equations. Okay? Maybe the easier one. Minus 2 times 5 is minus 10. Minus 10 plus 17 is 7. And those are the coordinates of n. So there's quite a lot of thinking going on, okay? You have to preempt things. When you look at the question, you should already know, I'm sure they're going to ask this, I'm sure they're going to ask that. Oh, they're giving me parallel lines, same gradient. I bet you they're going to ask me the equation of that line. So all those things must be in your head already, okay? All right. Yes, Diane. I see you raised your hand.
Excuse me, ma'am.
Please.
Ma'am, please, which question paper are we working on?
I think it's 2014, we said. Why?
Ma'am, I just wanted to print out the questions and have it neatly on my book.
Oh, nice. Wow. That's cool. Yes, it's, let me just show you. It's 2014, grade 12.
Thank you, ma'am.
Okay, so there we go. I think they asked you something else in this question as well. No, they didn't. It's a different question. Okay, we're going to look at 3.7 as well. Hang on. Let me share. I forgot to share. All right, so we finished 3.6. Oh, it does have something to do with that question. Oh, that's a pity. I'm not going to do it because now I've cleared everything. I'll rather do another question. Pity. And now what's going on? There we go. All right, let's look at this one. Right. In the diagram below, the equation of the circle having center M is that. Now, immediately when you see that, you must know that that is the standard form for the equation of a circle. And from the standard form, you can write down the center and the radius. And you must do it immediately. Okay, so it's the opposite sign for the x and the opposite sign for the y. And the radius is the square root of that. Okay. So minus 1 is, so in other words, M, if M is the center, then this is the point minus 1, minus 1. Okay. R is a point on the chord AB such that MR bisects AB. Now remember, if this is a center onto a chord that is the midpoint, then it is perpendicular. Right? Because remember, there's a circle around here. Not so? Oh, Allah. Yeah, there's a circle around here. They told you M is the center of a circle. They said that ABT is a tangent to the circle. And they're giving you a center N3T. O is a tangent to the circle having sin. Okay, so this is a little bit different. ABT is a tangent to the circle having a center N32. So like that. So do they not mean this? Center M, R is a point on a chord AB such that. Oh, and it's a chord AB. So this actually goes bigger than that. This is not a very nice question. Sure. Okay. They're saying that AB is a chord, which means that the circle goes through it. So in other words, it's something like, oh no, that's still not right. It's a chord, so it looks like this. So that's like, the circle is something like that. And remember, a line to the midpoint of a chord is perpendicular to the chord. Okay. And the tangent here is there. The tangent is at this point T41. And I think we've got all the information then, right? So what did they say? They said write down the coordinates of M, or we've done that already. And then they said determine the equation of AT. This equation. Right. So the equation of the line, right? And this equation of this line will have the opposite gradient to that because of the 90. But isn't this also 90, the angle between the radius and the tangent? So isn't this gradient also opposite to that? I can easily find the gradient of NT, right? 2 minus 1 over 3 minus 4. So that's 1 over minus 1, which is minus 1. That gradient is minus 1. So the perpendicular gradient, the gradient of a t will be the opposite. It'll be +1. And then I can easily find the equation of that line, right? mx, 1x plus c, and then I sub in the point. Right, so c will equal 1 minus 4, which is minus 3. So y equals x minus 3. Okay, so that is the equation of the line. Right, happy with that. I just want to move it up and see what else they ask. Oops. Okay, if it is further given that MR equals root 10 over 2. MR is root 10 over 2. Calculate the length of AB. MR, okay, how am I going to get this right now? Ah, there we go. MR,
Ma'am,
yes?
could we please repeat 4.2? Can we just do it one more time? Because I think I lost track.
Okay, so if you want to find the equation of AT, this line, and you can't, right? Because you only got 1 point on it. You've got no other information. So you can't find the gradient of the line. So you've got a point, but no gradient. So then immediately you know it's definitely got to do with some other gradient. And because of the 90 to the line, 90 means, the 90 degrees means opposite gradient. Either opposite to that gradient, which I don't have, or opposite to that gradient. So I'm going to find this gradient, NT, because then the perpendicular one will be the opposite. So 2 minus 1 over 3 minus 4. So 1 over minus 1, which is minus 1. So the gradient of this line is minus 1. The perpendicular is the opposite to that. Remember, perpendicular lines have opposite gradients. So if this is a minus, that's a plus. And this is 1 over 1, so this is the other way around, 1 over 1, which is still 1. So that means you have the gradient of the line and a point. Y equals 1x plus c, and then you sub in the point and you find c. Okay, so you have the equation of this line.
So, ma'am, for the coordinates, the 1 and 4, did we take it from the coordinates of t?
Yes, because that's the line, that's the point that is on this line. It's the only point on the line that they're asking you to find.
Okay, thank you, ma'am.
Pleasure. So you're using a bit of geometry here, hey? Perpendicular, perpendicular, etc. Was this 2 root 10 that they told me? I think I'm going to have to move it down again. Oh, sorry, root 10 over 2 and they want AB. Root 10 over 2 and they want AB. So they're saying that this is root 10 over 2 and they want the length of AB. I'm just going to use a different color here. All right, so they've given you this length. And they're giving you, okay, so this is the radius, right? So isn't that 3? It's the radius of the circle, so that's 3. So I can quite easily find AR using Pythagoras. And once I have AR, I double it to find AB, because remember, this is the midpoint. They said MR bisects AB. MR bisects AB, that's where I got the 90 from. I was using the theorem, the circle theorem. All right, so they're giving me that. I've got that, it's the radius, which is 3. There it is, square root of 9. which means I can use Pythagoras to find that and then double it. So how do we do Pythagoras? We find the hypotenuse and we start with that. 3 squared equals, and we add that squared plus that squared. So 9 equals 10 over 4, which is 5 over 2. So AR squared equals 9 minus 5 over 2. And if you work that out, you should get 13 over 2. You can check me. And then AR, if you square root, will be root 13 over 2. So therefore, AB will be twice that. Okay. So you're simply using Pythagoras. All right. But obviously, you needed to realize that if this was the midpoint, that was 90 degrees. And that when they gave you this length, that this was the radius because you got it from there. And then you have two sides in a 90-degree triangle, so you can do Pythag. Okay. And this is wrong. No one picked it, or did we? This is 10. Oh, it is right. 10 over 4, which is 5 over 2. I almost thought I made a mistake. All right. Any questions with that? You okay?
Yes, ma'am.
All right, cool. I'm going to stop there then. Yeah, okay, perfect. What would you guys like to do on Wednesday? I mean, Monday.
Ma'am, can we please do proportionality and similarity?
Perfect. We can. Perfect. Okay, super. All right, so I'll see you on Monday. Same time.
Thank you, ma'am.
Thank you, ma'am.
Cheers.
Thank you.